Alright, part 2 of the Unit 3 test review. So let's go ahead and identify the hypothesis and conclusion. Underline the hypothesis once and the conclusion twice. State whether each conditional is true or false. If false, give a counterexample. Okay, so remember, a conditional is in the form if P, then Q. Okay, where we assume the hypothesis is true almost always, and then the conclusion itself can either be true or false. So if we need to provide a counterexample, we're going to have to assume the hypothesis is true and then the conclusion is false. Okay, so can be true or false. So if the conditional itself is true, this has to be true, this has to be true. If the conditional is false, this has to be true and the conclusion has to be false. So let me go ahead and give you an example of where the conditional itself is false. So number one, if an animal is black and white, then it is a zebra. Okay, so this is my hypothesis, and this is my conclusion. Now let me go ahead and read that again. If an animal is black and white, then does it mean it's a zebra? Well, okay, so like I said, we're going to have to assume the hypothesis is true. Almost always the hypothesis is true. And yes, of course, an animal can be black and white, but does it strictly mean it's a zebra? Well, in order for me to, because I think this example is not true or false, and if it's false, give a counterexample. The reason why I think it's false is because there are other animals that can be black and white, and that would be a cow, right? So basically, okay, I'm thinking of an animal that is black and white, but it's not a zebra, and that example would be a cow. And this right here is my counterexample. This right here is my counterexample, right? So, yes, there's an animal that's true, and it doesn't have to be a zebra, so I can put false, and my counterexample would be cow. So what does it mean for the conditional itself? So I have a true, and I have a false, so the conditional itself would be false. Okay, hopefully that makes sense. Number 6, if I do not live in Terlingua, so that means I'm going to underline the hypothesis once, then I do not live in Texas, I underline that twice. So if I do not live in Terlingua, does it mean that I don't live in Texas? Okay, well, again, I'm going to assume the hypothesis is true because there are people who don't live in Terlingua, but does it imply that they don't live in Texas? This is false, and my counterexample would be you could live in Dallas, and that's my counterexample, right? So then if this is a true, this is a false, again, just like the previous, it's false. So the conditional itself is not true, so it is false. If angles are congruent, then the angles are vertical angles. So underline that once, underline this twice. So if angles are congruent, does it mean that they are vertical angles? Well, we've seen a lot of examples of angles congruent, right? And yes, one of them can be vertical angles, but there are others that show congruency. So again, we're gonna assume that the hypothesis is true, and these are vertical angles, by the way. If you have two lines that intersect to form a beautiful looking X, and then the angles across from each other are congruent, yes. But what if you have something like this? Because I know this is false, because if angles are congruent, it does not strictly mean that they are vertical angles, because I'm going to provide a counter example. And it looks like this. Okay, and we can see that this angle is congruent to this angle because they're both 45 degrees. So this is false. Now, if I were to say the converse of this statement, say if the vertical angles, if you have two vertical angles, then they are congruent, that will make sense. Okay. Number 8, this one's a little tricky. If I said if an angle is greater than 90 degrees, then the angle is an obtuse angle. Okay, I just want to make sure that you understand, because if you were to look at the key, it would say false, and that is correct. The answer on the key is indeed correct, because remember, an obtuse angle, just a little side note, an obtuse angle is greater than 90, but less than 180. Okay? Read the sentence one more time. If an angle is greater than 90, then the angle is an obtuse angle, and that is incorrect. So here, this is my hypothesis. That's my conclusion. You assume that the hypothesis is true, and of course an angle can be greater than 90, but does it imply it's an obtuse angle? No, because let's say that you have a straight angle, which is 180 degrees, right? This does not mean it's obtuse, okay? Again, obtuse is greater than 90, but less than 180. But if the angle is exactly 180 degrees, it is what we call a straight angle. Okay, so that means this is false. That's my counter example. So what does it mean for the conditional itself? It's false. Okay. Number 9, if a number is divisible by 5, then it is odd. So here's my hypothesis. This is my conclusion. So I need a number divisible by 5. And yes, any number can be, or not any number, there's some numbers that can be divisible by 5. And I'm thinking 20, right? And if I were to divide that by 5 here, well, 20 divided by 5 is 4, but is 4 odd? No, so this is false. That's my counter example. The conditional itself is false. If x is equal to 8, which I'm going to assume true, then 2x squared is equal to 128. So let me go ahead and plug that in. So 2 times 8. Okay, x can be 8. Right? So that's why I said true. So 2 times 8, the quantity squared, is equal to 128. I want to see if the left-hand side is equal to the right-hand side. So 2 times 8 squared. So 8 squared is 64. So 2 times 64 is equal to 128. Y'all, that's 128 on the left-hand side. Bring down the equal sign. Bring down the 128 on the right-hand side. That agrees. So this is true. No counterexample needed. Okay? But then we get into this territory, and many people missed this type of question on the quiz, and I want to make sure that you understand why that it is not x equals 12. So if x squared is equal to 144, does it mean that x is equal to 12? Does it strictly mean that x is equal to 12? No. So yes, x squared can be 144, but x is equal to 12 is not always true. So let me say this again. If x squared is equal to 144, does it strictly mean that x is equal to 12? No. No. Because your counterexample can be x equals negative 12. And this is just basically algebra review. Let me go ahead and tell you why. So if you have x squared equals 144 and you're trying to get x by itself, how do I get rid of the exponent 2? Well, you have to take the square root on both sides, right? So this and this will go away. So then I have x on the left-hand side, and then what's the square root of 144? Well, that's going to be 12, but don't forget, you got to tack on the plus or minus, right? So, yes, if x equals positive 12, right, then I get, well, 12 squared equals, well, what's 12 squared, or the 12 quantity squared? Well, 12 times 12 is 144. But then you can't forget that negative 12, so x equals negative 12. Well, that's going to be negative 12, the quantity squared. And y'all, negative 12, the quantity squared, is just like saying negative... It's like saying negative 12 times negative 12. And that negative times a negative becomes a positive, right? So that's going to be 144. So they're both 144. And like I said, if x squared is equal to 144, does it strictly mean that x is only positive 12? No, because this is your counterexample. So what does that mean for the conditional itself? Since this is a true and a false, the conditional itself is false. Number 12, if the slope of the line is 2 over 3, then the slope of the perpendicular line is negative 3 over 2. Okay, so remember the word perpendicular. Okay, so if the slope of the line is 2/3, so m is equal to 2/3, then the slope of the line perpendicular, by the way, is negative 3 over 2. So m perpendicular, you know the process of perpendicular. It's opposite sign, flip, fraction, right? So I'm going to flip 2 over 3, which is 3 over 2. And then since this is positive, this has to be negative. Does that agree? Yes. So, okay. This is my hypothesis. This is my... Oh, sorry. This is my hypothesis, and this is my conclusion, and therefore they're both true. So this is true. The conditional is true. I almost wrote false. You can tell. All right. So yeah.